I can't believe I'm doing this tutorial. Hello there everyone, my name is Crazy Killa, but welcome to a module I'm going to try and get through to the best of my ability, Buttonage. So this module is a series of buttons. It's very distinct. It's another 64 grids, 64 button, 8 by 8 grid, and as we can see we have a bunch of different buttons here. They can be different colors, blue, green, orange, pink, red, and yellow, along with a series of different buttons as we can have present. We can have P buttons present, we can have special buttons, which in this case are going to be represented by a white button in the center, the red border around it, and the red M that will be appearing. It will always be exactly that set for special buttons. That's going to be the way this appears. There are also going to be black and white buttons, just as I forgot to mention. But that's essentially what we're going to be doing here, is we're going to be trying to find to press one button out of this series of 64 buttons with a series of funny calculations that my main man Exish has never solved before as of this tutorial. So let's get right into this. So what we need to do first is we need to simply add the sum of each of the button's colors values together, and black and white are excluded in this step. So the way that button colors are determined is going to be by this sort of central bigger portion here. The border itself is going to be the color that's around it. So in this case, for this first one up at the top, the button is orange. The border is red. That's going to be the way that this works. The button, same thing with the next example. The button is red. Its border is white. So that's going to be the way that this works. Hopefully that makes sense. But essentially what we're going to be doing is we're going to be first focusing on the individual colors, individual buttons' colors, and we're going to be essentially adding these guys together. And one of the ways that I actually like to do this is I actually like to just make it and play it safe a little bit, which, by the way, special buttons are going to be included in this step. Everything with a P is also going to be included in this step. So if you happen to have some sort of, well, I mean, special buttons won't be included in this step, but for later steps, if you happen to have a white button, which in this case will be used for the second step, special buttons still do apply in this instance. There's only one case that the special buttons are going to be specifically distinct, which in this case we'll get to in just a minute. So, what I generally like to actually do first is I actually like to focus on getting the individual button colors and making sure that everything adds up to 64 the way that I want it to. It's sort of a way to play it safe, and it's just actually much easier to do this without having to essentially just use your calculator and add all individual buttons row by row. It's just much easier to play it safe that way. Let's do blue, green, orange, pink, red, and yellow. Now, obviously, you can do this whichever way you so please, but I like to keep track of it. I like to play it safe. This module is a tedious sucker, and I'd rather have it be a little bit more mathematically consistent. So first things first, let's note down our blue buttons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 blue buttons, and I'm also going to note down black and white as well, black and white. So let's get green next. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's going to be another 9. Okay. Orange, we have 1, 2, 3, 4, 5, 6. Looks like it's going to be 6. Okay. For pink, we have not many. Doesn't appear to be. We have 1, 2, 3, 4. Only 4 of them. Interesting. For reds, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's going to be 14 for you, quite a few. Yellow is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, solid amount. Black is going to be a couple of them. 1, 2, 3, 4. It's only going to be 4 of them. And white is going to be a 1, 2, 3, 4, 5, 6, 7, 8, 9. And now what we want to do is we want to make sure that all of these sum up together. Make sure they add up to 64 because that's the amount of buttons we have present in this grid, and all colors need to make sure we need to make sure that they were counted correctly. 9 plus 9 plus 6 plus 4 plus 14 plus 9 plus 4 plus 9. And indeed they were. Perfect. That's going to help us for later steps because what we have to do now is we have to add the sum of each of these buttons' colors values together. And then we're going to be subtracting black and white. So first things first, we need to determine the values of each of these buttons. So blue is going to be worth 1, and essentially what we're going to be doing here is we're going to be multiplying each of these individual values by the amount of buttons that we had present in each of these colors. So we have blue is worth a value of 1. 1 times 9 is simply going to be 9. Green was worth 2. 2 times 9 is going to be 18. Orange was worth 3. 3 times 6 is going to be 18 as well. Pink is going to be 4. 4 times 4 is worth 16. Red is going to be 14. 14 times this by 5 is going to be a 70. Then we have, for our last color, yellow. Yellow is going to be 6. 6 times 9 is going to be 54. And now what we need to do is we need to then subtract the sum of each of the black and white buttons. Black is worth 1, so that's going to be just a value of 4. And white is worth 2. 9 times 2 is going to be 18. Okay, so we're going to add up the sums of each of the colors, in this case blue, green, orange, pink, red, yellow, and we're going to subtract the black and the white. So we're going to do 9 plus 18 plus 18 plus 16 plus 70 plus 54, and then we're going to subtract 4, and then we're going to subtract 18. We're going to start off with a value of 163. So now, what we need to do for the next couple steps is we're then going to multiply by the number of special buttons. And as I mentioned beforehand, special buttons are going to be the white, red border, and the red mic. They're only going to be, the easiest distinction is going to be just the mic. The mic does not appear on any other buttons except these, so we're going to essentially be looking for the red mic. So in this case, the special buttons that we have is going to be 1, 2, 3, 4, 5. So we're going to have 5 special buttons, and we're going to multiply this value of 163 times by 5, giving us an 815. Okay, next up, we're going to add the number of P buttons. Now this P is not specifically some yellow buttons can have an orange P on them. It's going to specifically be yellow, so that shouldn't be too hard to find. So we have 1, and obviously some red, green, and blue have different papas, but essentially that's just going to be just a papa randomly appearing. So let's count up the total of the papas here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we're simply just going to be adding 22 to this, 837. And now for the final step. Then change the number based on the button's border, and red borders are excluded in this case. So we have, now what we need to do is we need to count the borders. In this case, we have gray, pink, and white. We also have red to count as well. Let's count the reds just to get them out of the way, and make sure that they are just simply going to be modular with 64. So let's take a look. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 18 for the red. Okay, so we're simply going to be excluding these guys. Now let's figure out what the other ones of gray, pink, and white are going to be. So gray is going to be a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 for the gray. Now, as you can see, the reason why I'm doing this is just for the explanation of the actual module, but also this module is very error prone, and it is very easy to mess up even one number. So this is kind of just why I'm playing it safe and making sure that I get this done successfully while teaching you the concept of the module. So let's take a look. So we have pink now. So pink is going to be worth, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. Okay, it's going to be 15. Now, if everything is correct, so we have 64, we're going to subtract 18, we're going to subtract 30 from the two 15s, we should have a total of 16 whites. That should be what we have here. So let's count. So we have 1, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh boy, we counted somewhere wrong. Unless there was obviously just some cases where you can't have it. Let me make sure. Alright, so let's make sure that we got this correctly, because we obviously need 3 more whites. Maybe I just missed them. So 1, 2, 3. I feel like I should have more pinks. I feel like I definitely should have a lot more pinks. 4, 5, 6, 7, 8, 9. Here we go. 10, 11, 12, 13, 14. Okay, so we found one that we might have missed. Now let's make sure that we counted the grays and the pinks right. So gray, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so there's a 16 right there. Yep, so 16 gray. Let me make sure this adds up now. So we have 16 plus 15 plus 14 plus 18. One minute. We're missing one more. Let's count the pinks again. Okay. We have, it's probably what it was that I missed with the highlighter, so apologies for that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Still getting 15. Maybe it's another red that we missed somehow. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. No. Let's count right again. I'm sorry, I'm super duper paranoid about this, and I don't know why I am, but I am. 1, 2. I'm going to pause the tutorial real quick, just to make sure I get this right. Apologies for that taking so long. I was missing one single pink, and it was this little bugger right here, this little yellow-purple guy, the yellow-pink guy. But now that we have our total values here, this is exactly why you make sure, because it is very easy to miss stuff like this. Now what we need to do for our last step here is we're going to then change the numbers based on each button's border. And as we can do, we can now make sure 16 plus 16 plus 14 plus 18 does indeed add up to 64. We're not worried about reds though, so we're just simply going to not worry about this. For grays, what we're going to do is we're going to be subtracting 1. Now, one of the other things that you can also realize here is that the pinks are going to be adding 1. And both the gray and the pink are essentially the exact same value, because it's going to be subtracting 16, and then the pinks are going to be adding 16. So they effectively cancel each other out. Perfect. And now for white, for each individual white border, we're going to be adding 2 to this. So 2 times 14 is going to be us adding 28 to 837. Which should be right, yes? I believe this one added the 22s. Yeah, so hold on. So 163 times this by 5, plus the 22. Yes, this does make sense. So, and then adding the 28 is going to be 865 as our total here. And then we're going to finally modulate this number by 64. And this is going to be the correct button number. So modulating by 64, which is essentially subtracting 64 until it is lower than 64, is going to result in 33. Now, you might be thinking, oh, well, let's go submit 43 immediately. Let's go blah, 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 blah. This is our correct button. However, if the last digit of the serial number is even, the buttons are in reading order. In this case, the last digit of the serial number is odd. It's not true. So it's going to be, if the last digit of the serial number is odd, the buttons are in Chinese reading order, in this case being top to bottom, left to right, where top right is 0. So if it was in reading order, the top left button would be marked as 0. In this case, it would be reading order. You know how reading order works, left to right, top to bottom. But in this case, the top right is going to be where Chinese reading order starts, and then it's going to be starting on 0. We will always start on 0 wherever you start. And then now what we're going to do is we're going to go counting down by the number of rows. And in this case, what we can do is we can do, for example, go column by column. We can do 8, 16, 24, 32, and then we can go down 1 to 33. And just like that is a solved module. Now you understand the hell of this module, and exit, I swear to God, please solve one. At this point, I've done the bloody tutorial, and I've gone through hell and back to explain how this thing works. I kid you not, I spent at least a good solid 5 to 10 minutes trying to figure out where this bloody pink was, and I couldn't find it. So, yeah, there you go. That's all I'm going to do. I really don't have the patience to do 2 of these, but that's essentially how this module works, is you're just doing basic addition / multiplication, and of course subtraction as well. But that's all you're essentially going to be doing with this module. It is a nightmare to do, and it is not fun to do. So, as always, thank you guys for watching. Remember to stay crazy, stay cool, and thank you for watching me go through this hellhole. I'll see you guys in the next one, and bye-bye.